Well, good morning, Algebrains. Sorry I can't be with you. And I'm here to finish the review. So I hope you have your papers out, uh, your study guides or practice tests, whatever you want to call them, and let's get started. We got to get this covered before the bell rings. So we got a lot to do left. Write an explicit formula for the nth term of the arithmetic sequence. You will be given in the on the test form itself. It's got the recursive and arithmetic sequence forms written down. So I'll give them to you here in the notes. You can write them down as well. This is the explicit formula. A sub n equals a sub 1 plus n minus 1 times d. That's explicit. Recursive, you have to list the a1 value, and then you have to say a sub n equals a sub n minus 1 plus d. So that, double check that, make sure I gave you the right thing. Recursive a sub 1, yep, that's all you got to do. Okay, so, yeah, so this one, in the example here, it asks for just the explicit formula. On the test, you're going to have to do one of each, but, these aren't that hard, so suck it up. Here we go. A sub n equals a sub 1 plus n minus 1 times d. A sub n equals a sub 1, the first term is 8, plus n minus 1 times, your sequence is going up by 6s, so 8, 14, 20, 26 is up by 6s, so times 6. And then just simplify it. A sub n equals 8 plus, we have to distribute here, so that would be 6n minus 6. And then 8 minus 6 is 2, so the final form would be this, a sub n equals 2 plus 6n. This is the answer I'm looking for. Okay? Should be okay, especially since we're giving you the formula. Whoops, that was not what I wanted. There we go. All right. Table below shows the cost of renting ski equipment at a ski lodge. Write a linear function f for the sequence and graph the function. So write the linear function, we're writing it in function notation since it's the linear function f. So f of x, my x column is going, or row is going up by 1s. That's the way I want it to go. So what is my y column doing? It's going up by 5s. 14, 19, 24, 29 is up by 5. So I need a 5x. And then if I back up 5 from here so that I had a 0 in my x column, subtract 5 from here, and that would be 9. So I need a 5x plus 9. And then we need to graph the points that we've got. So this is a weird graph. The bottom x values down here is numbered by 4s, which I think they do that on purpose to see if you're paying attention, to see if you just count by 1s and aren't even looking. So the easiest spot to graph would be 429, since it's labeled 4. There's 25, 20, 22 and a half, 25, 27 and a half, 29 is going to be clear up at the top. 29 is going to be right up here. And then 324 would be halfway here. 324 is going to be just below the 25. And then 219, 215, 19 is going to be right there, just below the 20. And 114. So there's 1 just below the 15, right about there. And then we graph that with our handy dandy straight line tool. something like that. Okay. That's it. I don't know what else to say about that one. Graph it, draw the line. What type of association is shown by the data in this scatter plot? Well, this clearly is a negative association. It's going down from left to right. So it is a negative association. Which equation best models the data shown in the scatter plot? This is an interesting question. I would suggest using one of the little clear plastic rulers and laying it on the on the graph for each one of the lines, just to see where it's at. I can do that fairly easily with this by using my straight line tool. So let's just try each one. Y equals x minus 3. So if I start here at minus 3 and I have a slope of 1, that does not model that data very well, because there's the ends are too far away from the middle. You've got 2 dots above and 4 dots below, so I don't like that at all. That x minus 5, so here's a 5, and kind of again going with the slope of 1. That one's maybe, well, really it's no better at all. Only got 1 dot below, you got 4 dots above, and these are that one's pretty far away, so I don't like that. So the slope's wrong on those that have just a slope of 1. So 3x minus 3, well, we didn't like minus 3 a minute ago because it put too many below the line, and I think this one makes it even worse. There's too many below the line. They're all below the line. So we don't like that. So by process of elimination, we've gotten it down to this one. So 3x plus 5, or 3x minus 5. Something like that. It's pretty close. So dots are all really close to the line. You got 1, 2, 3 that are right through the line, and then, well, really 4 that are through the line, and 1 that's below. So 1 below, 1 above. All right, I like that one best. D, you just have to kind of play with that one. You guys know how to graph lines, and just graph the lines and then find the one that fits best. All right, when Hannah goes to the mall, sorry, my chair's squeaking so much. I'm trying not to move too much, but it's bugging me. Don't imagine what it sounds like on the recording. Hannah goes to the mall. She buys the same lunch and also buys the same books. The table shows the number of books she buys X and the total amount of money she spends Y. Make a scatter plot of the data. Tell whether there's a positive correlation, negative correlation, or no correlation. Then, if possible, draw a trend line. If possible. Of course we can draw a trend line. We're wizards. All right, so 117. I don't know, probably about there. 221. A little bit above 20 there, and then 223, so just a couple higher right there. 326, right about there, and 434, kind of in here. Okay, we've talked a lot about this, the idea of drawing trend lines, and I know it makes you guys nervous a little bit, but you know what? You get a close trend line on there, and it's going to be fine. I don't want one like this. That's not a good trend line. That would be worth no points. You know, I don't want this one. That's not even close. There's not a good trend line there. So a good trend line is going to have, you know, a slope that matches most of the points. It's going to have as evenly spaced as best you can above and below the line. That's a pretty good trend line right there. Yours may be a little different than mine, but that's pretty close. All right, and then does it show a correlation? Well, yeah, it does. It shows positive correlation. Whoops, can't write with the straight line tool. So, whoops, positive correlation. I think you guys are pretty good at picking out positive and negative correlations at this point. All right, next page. Number 32. which statements about the trend line in item 31 are true? I hate it when they split a page like this because you got to kind of look back. I can see my notes and look back at number 31, but you'll have to flip back and forth a little bit. The slope is the cost of one book. Well, as you look at the table, the table said, doggone you. Sorry about that. The table says that when she buys one book, her cost is 17. When she buys two books, it's 21. 2 is 23. So the more books she buys, it tends to go up, right? But the slope is the cost of one book. I like that. The slope of the line, as she buys more books, the line goes up. The line is going up because she's buying more books. So I like letter A, and I'm going to stay here on this screen. So I like letter A. We're on number 32. 32, I like A. And then if I like A, then I must not like B, because B says the slope is the cost of Hannah's lunch. That doesn't make sense. So she only buys lunch once, but she buys books over and over again. And so that doesn't work. Part C, or number C, the y-intercept is the cost of one book. Well, that doesn't make sense, because if she doesn't buy any books at all, she still has a cost. That's what the 0 here would mean on the x-axis. It would mean 0 books, but she still has a cost. And so that must mean D is true. The y-intercept is the cost of her lunch. So D is true, that the y-intercept is the cost of Hannah's lunch. Okay, so it's weird doing that question while I was on the other page, but there we go. It's A and D. Hannah drew a trend line for the scatter plot in item 31, and she found her equation to be y equals 5.5x plus 11 to represent the line. So use her equation to predict how much she will spend if she buys 8 books. So 8 books, 8 goes into the equation, and books was on the x-axis, so we're going to put book 8 in for x. Y equals 5.5 times 8 plus 11. Well, 5 times 8 is 40, and then another half of an 8 would be 44. So 44 plus 11 is 55. Y equals 55. So if she buys 8 books, we would expect her bill to be somewhere around $55. Calculator screen shows the linear regression for the data in the table. What type of correlation does the correlation coefficient indicate? Correlation coefficient is the R value. And remember, it runs from -1 up to 1. From -1 up to 1. The closer it is to -1, the stronger the negative correlation. The closer it is to +1, the stronger the positive correlation. And if it's right at 0, then there's no correlation whatsoever. Okay, so we look at the R value. The R value is -0.99. So that's really, really close to -1. So that's a strong negative correlation. It's strong because it's really close to -1, and it's negative because it's negative. Number 35, write the equation for the line of best fit for the data in item 34. Round the values to the nearest whole number. This is a little different than we did on our calculators on Desmos when we were working with Desmos. It didn't use the letters A and B. It actually used the letters M and B. So the good news is B is the same thing. B is just y-intercept. And for some reason, some calculators are programmed to use A for the slope instead of M. I don't know why they do that. It just makes life more confusing than it needs to be when they monkey with variables like that. But guys, all we have to do is this: y equals, it even tells you here, ax plus b. So the a value goes where your slope is, and it says to use round nearest whole number. So -1.9 would just round to -2. -2x, and this 19 is positive, so it's plus 19. Okay. Question 36. If I'd have had the foresight, I would have changed this question a little bit to make it match up better with what the test does. the question says make a residual plot. I've included a residual plot for you. This is the residual plot. You don't have to make one. You won't have to make one on the test. Don't worry about that. But we do need to do some work with residuals, and we're going to do that work. Actually, yeah, we're going to do that work right here. Okay. So make a residual plot. We're not going to make a residual plot on the test. I don't want to do this, but you will have to calculate some residuals. Guys, it's simple. It is simple to calculate residuals. This is our equation for the line of best fit. And here, if we go up a little bit, this is our data. These are the actual points that were plotted on the graph. So we want to see how good our equation is by testing these data points. That's all this residual plot is done. On the test, you're not going to have to make a residual plot. You're just going to have to calculate the residuals, and you're going to have a table, and the table is going to have the same x values as your data set. So it's going to have the x, and it's going to have, like for our table here, it's got 1, 3, 4, 5, 6, 8, 9. 1, 3, 4. I didn't leave enough room. 5, 6, 8. Oops. 9. 1, 3, 4, 5, 6, 8, 9. 1, 3, 4, 5, 6, 8, 9. Now, I calculate what each of my y values would be using this equation. So what is negative 2 times 1? Negative 2 plus 19 would be 17. My equation says I should get a 17 here. What did I actually get? Oh, look, I actually got a 17. So what's my residual? It's on the x-axis. My residual value is 0. It nailed it. That's right where I want it to be. I'd love it if all of them were there. That would be perfect. But we don't live in a perfect world. My next x value is 3. The graph predicts, or the actual data says the number is 12. But what does my equation predict it will be? Well, negative 2 times 3. Negative 2 times 3 is 6. Or negative 6, sorry, negative 6 plus 19. Negative 6 plus 19 equals, negative 6 plus 19 equals 13. So my equation says it should be a 13, but what was my actual data value? My actual data value was 12. So 13 is one, my actual data, sorry, I'm getting tongue-tied here, is 13. I'm off by 1, right? So my equation predicts that it would be 13, but my actual data set was 12. That's 1 less than the prediction. So look where the residual plot is. It's 1 below the x-axis because the actual data was 1 below the line of the trend line. All right. So what is this one? Well, I got to put a 4 in. Negative 2 times 4 is negative 8. Negative 8 plus 19, that's 11. And so the equation says it should be 11, but my actual data was 12. 12 is 1 bigger than 11. So look where my data, or my residual plot is. It's 1 above the x-axis. All right, do you see where we're going with this? So now put a 5 into the equation. Negative 2 times 5 is negative 10. Negative 10 plus 19, that's 9. The equation says it should be a 9. What was my actual data value? It was a 10. That's 1 above 9. So look where my residual plot is. It's 1 above the x-axis. All right. Now, on the test, I don't know why I'm spending so much time talking about this thing. You're not even going to have one of these. This doesn't even matter on the test. Okay. All that matters is that you can fill out this table. So can you take this x value and put it into the equation that you have for the line of best fit? Negative 2 times 6 is negative 12, plus 19, that's 7. Negative 2 times 8, that's negative 16, plus 19, that's 3. And then negative 2 times 9 is negative 18 plus 19, that's 1. All we got to do is fill in those x values. Okay? So don't freak out on that one. That's question number 25 on the test. That part will be on Friday. And if you freak out on it, maybe we'll make it a bonus question or something. All right. Use the equation you wrote in item 35 to predict the value of y when x equals 10. So we wrote this equation back here, y equals 2x plus 19. We need to predict what x will be, or what y will be when x is 10. Show your work. Y equals negative 2 times 10 plus 19. So y equals negative 20 plus 19 equals negative 1. So negative 1 is my prediction. And then they ask, is it an extrapolation or an interpolation? Well, that's really easy to answer. How high did my data set go? My x values went from 1 through 9. And so I built my graph, I built my equation, everything I built was on a data set that goes from 1 to 9. And then they asked me about, well, what about 10? That's outside my data set. Outside is like an exit sign. It's extrapolation. It's outside the data set. So this one is an extrapolation because it's outside the data set. If they'd asked me about the number 7, if it's right there, that's inside the data set. So that would be an interpolation. Okay? So 10 is outside the data set. It's an extrapolation. Okay, we're cooking here. We're doing great. Number 38. Each month, Nadim keeps track of a number of times he visits the library and the number of books he checks out. Is there a correlation? If you model his data with a linear equation, is there a causal relationship? This example isn't, I think, is a little trickier than the one that's on the actual test. What we're looking at here to tell if it's a correlation, we want to see as x increases, does y increase or does y decrease? If y increases with x, then that would be a positive. If y decreases with x, then that would be a negative. Well, this one's tricky because of this first one right here. He went 3 visits this month or whatever and got 12 books. But then after that, he visited 4 times, got 5, 5 times got 6, 6 times got 8, 7 times got 9, 8 times got 11. If we leave this one out, if we leave this out as an outlier, then it's pretty clear we have a positive correlation. If we throw this one in there, sometimes that one data point makes it look like there's no correlation, but outliers we don't worry too much about. Okay, so that's a weird one. All the other ones show us that there is a positive correlation. Okay, so that kind of tells us right there, well, there is a positive correlation. I like that part. I don't like that. I don't like no positive correlation, and I don't like no correlation at all. So this really is the only one that makes sense for this one. There is a positive correlation and no causal relationship. By the way, this word right here, causal, that has to do with causing something to happen. That's a tough thing to prove. And so most of the time for stuff that we're doing, we're going to say, it's hard to say there's cause. That might be a hint for the test, by the way. So I don't like us just to say there's cause very often. We have to be pretty sure that of what we're doing to say that there is a causal relationship. All right. Identify the domain and range of the relation. This part should be super simple. Domain is just the x value. Don't forget the fancy brackets, -5, -2, 1, 5. That's all it is. Domain, range, 10, 11, and 4. That's a horrible looking comma there. Let's try that again, comma, 4. All right. Notice we don't, the 10s get repeated here, but we don't repeat things inside the set notation. All right, domain and range. Now, which of these statements best describes the relation shown from item 39? And we didn't spend a whole lot of time talking about these relationships. The easiest way to judge these is to make one of these mappings. We didn't do a lot of these, but this is the best way to do it, I think anyway. If we put our domain here, -5, -2, 1, and 5, we put our range here, 10, 11, and 4, and then we draw arrows. So -5 goes with 10, -2 goes with 11, 1 goes with 4, and 5 goes with 10. So first of all, do we have a function? Well, this is my x value, it's the domain, this is the y value. Every domain only has one arrow going away from it. So that means that it is a function. So it is a function, so that we're going to eliminate that one. So now, is it many to one, one to many? All right, a function or one to one. Well, it's not one to one because this one has two things pointing at it. But each one of my domains has only one thing going away from it. So it is a function that is many to one. No, I said that backwards. Phooey, that's not even what I have circled in my notes. Many things. No, it is the one I have circled in my notes. I looked at it backwards. It is many things pointing at one range. There are many domains pointing at one range value. So it is many to one. Sorry about that. I got tongue-tied there for a second. So many to one, yeah. If we had, well, anyway, you can reason that out. There are many things pointing at one object. 41, which of the relations are functions? Select all that apply. So first look at, if you have a list of ordered pairs like this, first thing you do is look at the x values, 3, -1, -3, 0, and 2. Since none of those values repeat, they're all different numbers, automatically we're going to say that's a function. For this one, this is a mapping. We've got this domain, -4, that has two arrows going away from it. So this domain value has two outputs. This one input value has two outputs. That means it is not a function. It is a relation. Look at C. Here's my x values, 1, 2, 3, 4. That means it has to be a function. And then if it's on a graph, we do the vertical line test. And that vertical line test, let me get my vertical line drawn on here. There's a vertical line. And if I grab a hold of this thing, then it's, as I pass it over the points, there's a point right there, right here. It's touching one point. But when I get here, look at that, it's touching 2 points. There it's touching 2 points. That means not a function. So that is not a function. All right, so that got done with the original packet. I've got some extra that this should tell you something about about the test, because there were a couple of problems that weren't on the review that I saw on the test that I wanted to go over. So I don't think they're super difficult. I just want to make sure that we go over them once. Which relation is not a function? So 7, the x values repeat. So then I have to look at the y values, 3 and 6. Those don't repeat. So that is not a function. All right, -4, 0, 7, 4, -7. Those x values are all different for B, so that one's a function. 4, 8, 12, 16, 20. All the x values are different for C, so that's a function. 1, 3, 5, 7, 9. All of the x values are different for D, so that one's a function. So the only one that we can answer there that's not a function is A. All right, another one of these. This one's pretty simple, but we'll just do it anyway. 5, 10, 15, 25. And then the range is just the y values, and that is -3, -3, -1, 1, and 3. What is the best description of the function in item 2? Whoops, item 2. Got to look back at that one. So, is it a function? Yes, because each of the x values only has one arrow, so it is a function. Well, so it can't be D. And every arrow is only pointing at one thing. So it comes from one thing and it goes to one thing. So that means it is a function that is one-to-one. Sasha sells t-shirts. Each day she earns a set amount plus a commission. Write a linear function to determine Sasha's pay. There's already an f of x there. I started to write f of x. So f of x equals, well, what's happening in the y bracket? 68, 71, 74, 77, 80. That's going up by 3 every time. So that means I got to have a 3x. And then if I back up 3, put a 0 here, because I've got to have a 0 for the x value to find the y-intercept. So if I back up 3, that's going to be 65 plus 65. So that's maybe like a setup fee for printing the shirts or something. And then, so if you could have them set up all their stuff and order no shirts, you still got to pay them $65. All right, last one. What is a reasonable domain for the function in item 4? Well, I mean, we could buy more than 3 shirts, so I don't like A. 50, that's not a bad one. We're going to leave that one there. Let's look at these others. 68 to 80. Well, that doesn't make sense. That's the y values, 68 to 80. We don't want to say you have to order 68 shirts and can't order more than 80. That'd be a weird thing to do. Sometimes this is a good choice here for D for what your domain should be, all real numbers. But does it make sense, first of all, for negative numbers? We can't have negative t-shirts. And then does it make sense for like a billion to be the number? Probably not. So we're going to get rid of that one. And B seems to be the best answer. Up to 50 shirts for your team or whatever should work. All right, guys, that takes care of the review. I think it's going to be okay. We should know how to do all of these things. I might, be able to point you in the right direction on the test day or something, or I'll try to spend a few minutes doing a little bit of review right before I hand the test out each day, just to go over 1 or 2 things for that day's test. So be at peace. It's going to be all right. We'll make it okay.